Welcome back to this channel, Electronic and Electrical channel. So in this session, we will look into another type of example for logical combination logic circuit. So far, we have looked into two type of example, multiplexer and adder. Now in this session, we will look into encoder. Encoder is an example of combination logic circuit, which is in unit 2. So this will be the final topic. So we have two topics, that is encoder and decoder. In this session, we'll focus on encoder. Encoder, as I said, is the example of combinational logic circuit where it will have multiple input and multiple logic output, which is converted from one coded to another coded, where input and output code should be different. Now, for example, if you have an input binary number, then your output should be another type of number. It has 2 raised to power n input line and it has n output line. So encoder will accept the active level on one of its input, which represent digits such as decimal or octal digit, and it will convert to coded output such as BCD or binary. Now, as in the first sentence, it says the output and input code are different. So it says if your input is decimal number, then your output should be binary or either BCD. Encoder can be a device which will encode various symbol and alphabetic characters. So definition of encoder is the process of converting from familiar symbol or number to coded format is known as encoding. Now this one is general structure of encoder. Encoder has number of input line, only one of which input is activated at a given time. Now in order to have output, only one input is activated at particular time. Depending on which input is activated, you will have output. So if you look out here, so this one in the middle one is the encoder, and this one is input and this one is output. Now with the help of this device, that is encoder, the input is converted to output. Now for example, you have input 3 selected. So you have a decimal input and your number 3 is selected from the input side, and this 3 is fed to this device, that is encoder. With the help of this encoder, then this will convert to BCD output, which means binary output. So 0013, so equivalent decimal number will be 3. Now suppose if you select 5 and fed to this encoder, then your BCD output will be 0101. So which means where equivalent decimal number should be 5. So in the name itself, it says decimal to BCD encoder. So therefore, this type of encoder will convert decimal number to BCD output. Now, in this figure, it shows the simple decimal to BCD encoder. So this is the encoder, the simple decimal to BCD encoder, where you have 4 output, Q0, Q1, Q2, and Q3, and you have 10 input, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you have 0. So if you do not close the switch from 1 to 9, so your output will be 0. So therefore, you have 10 input when you include 0. So they are used to generate coded output from the single active numeric input. So simple decimal to BCD encoder is used to generate the coded output from the simple active numeric input. With the help of that simple decimal to BCD encoder, your numeric input will convert it to the coded output. The decimal to BCD encoder usually has 10 input and 4 outline. So you have 10 input and 4 outline. To illustrate this in the simple manner, let's take a look at a simple decimal to BCD encoder, which is shown in this circuit. Now in this circuit, when the circuit is at idle condition, all line will held high. All the line from 1 to 9 will be held high with the help of this pull-up resistor. Now, when all the switch 1 to 9 is open, with the help of pull-up resistor, your line will be high, and at that time your output will be 0. Q0, Q1, Q2, Q3 will all 0. Now, if you look at this circuit, if you turn on at switch 1, so can you look at which output is connected to switch 1? So only Q1 is connected at switch 1. Whereas Q2, Q1, Q2, Q3 is not connected to switch 1. Only Q0 is connected over here, out here. So therefore your output will be, so Q3 is MSB. So your output will be 0001. MSB is Q3 motion. So 0001. Q0 is LSB, your LSB. So therefore LSB is 1, MSB is 0, and is 0, this one 0. So therefore 0001. So therefore, since you have given out input 1, so the output should be equivalent to decimal number 1. Now if you look at 9 and 9 tawachin, so if you close the switch, which output is connected? Q0 is connected over here, Q3 connect binu, Q1 and Q2 are not connected. So therefore your output will be 1001. And 8 mush and a 1. 8 plus 1, which is equal to 9. So therefore you have output which is equivalent to decimal number 9. So as per the definition of encoder, your output of the encoder will depend on the input that activate at that particular time, and you can activate the input only one at a particular time. So you can't activate input two input at the same time. For example, if you activate 9 and 8 at the same time, so the output will get confusion, which output should display. So therefore you have another type of encoder which is known as priority encoder. If you have all input given at the same time, so there is one circuit which is known as priority encoder. So this will solve the issue. But if encoder is not priority encoder, you cannot activate your input twice at particular time. You should activate your input only one at a particular time. Now in order to have your output which is equal to decimal number 2, you should activate switch at 2. And at 2 na biauchin, which one is connected to switch 2? So Q1 is connected. So 0010. So therefore your decimal number is, your output is 0012, which is equal to decimal number 2. To generate BCD output that is equivalent to single selected decimal input, the switch corresponding to the decimal is closed. Here the switch acts as the active low input. So if you have any doubt, please, you can ask me at any time. Now, if you have understand the concept of simple decimal to BCD encoder, let's look at the truth table. So you will understand the truth table easily if you have understood the concept of this decimal to BCD encoder. Now, sorry for this invisible input. So I will read out the input. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the input, and you have output Q0, Q1, Q2, and Q3. I think you should interchange this one. Instead of Q1, Q0 here, it should be Q3, Q2, Q1, and Q0. Because because we have considered Q3 as LSP, and Q3 as MSP be considered. So MSP should be out here, and Q0 is LSP, so therefore Q0 should be here. Q3, Q2, Q1, and Q0. Please keep in mind to interchange this one. Now, as I said, at the ideal condition, with the help of pull-up resistor, all the line is high, but your output is 0. Because when at the ideal condition, with the help of pull-up resistor, your line is high. However, you have not activate any of the switch 1 to 9 switch mabibate. So therefore, your output will be 0. At Q3 and Q3 Q3 0 0 0 0. So therefore, your decimal equivalent output is 0. When you don't close the switch from 1 to 9, you have output 0. Now, when you close the switch at 1, and a switch 1 about the input 1 so active low is high now. So we consider that switch as active low. So active low is high, which is denoted out here L, which is high now. It has become high. So therefore your output from Q1 will be, Q0 will be high. And a Q3, Q2, Q1, Q0 base is. So therefore this will be high, rest will be 0. So therefore 0001, which is your equivalent decimal number is 1. So your input is 1. So it should be, your BCD should be equivalent decimal number to 1. Similarly, if you look at out here 9 so when you turn on switch at 9, so the output you turn on will be Q3 and Q0. So therefore on a high rest 0. So therefore 1001, which is equal to equivalent decimal number 0. So if you have any doubt regarding this two table, please don't hesitate to ask me. Now let's look into the type of encoder. We have different type of encoder. So so octa to binary encoder. So you have octa to binary encoder, which means you have 8 input. So octa to binary encoder. So 8 input and 3 output. So it has 8 input, 1 of each octa digit, and 3 output that generate the corresponding binary code. It is assumed that only one input has a value of 1 at given time, otherwise circuit is meaningless. So which I said, in order to have your output, one input should be activated at a time. If you activate more input at the same time, so it becomes meaningless. So if your circuit should work, if you activate more than 1 or 2 input, so that circuit should be priority encoder. Otherwise, your circuit become meaningless. When all input are 0, then output will be 0. Now, the 0 output can be generated when D naught is equal to 1. Now, if you give D naught equal to 1, so if you look at the circuit out here, your circuit A, B, C, that output A, B, C is not connected to D naught. So raise D1 to D7 is turned off. D1 is given 0. So therefore your output will be A equal to 0, B equal to 0, C equal to 0. So therefore output will be 0 when you turn on, when you give D1, D0 equal to high. Now when you give D1 equal to high and turn off raise, then if you look closely, the output connected to D1 is C. So therefore, this one is MSP, and this one is LSP. So therefore 0, 0, 1. So therefore, when you give high to D1, your output will be 0, 0, 1, which is equivalent to decimal number 1. Now similarly, if you turn on D7, so if you look at the circuit, all the output A, B, C is connected to D7. So which means you have output 1, 1, 1. This one is binary number. So 111 beochin equivalent decimal number is 7. So in this way, you will convert your input decimal number to binary output with the help of octa to binary encoder. Now this one is truth table for 8 octa to binary encoder. So if you study yourself, you will understand the truth table. Now I have mentioned priority encoder. So design of 4 to true priority encoder. Now priority encoder is a circuit where you have more than 2 input at the same time. Now you have, for example, 4 to 2 priority encoder. So you will have 4 input and 2 output. D0, D1, D2, D3. So you have output X, Y. So you have 2 output. The priority encoder is the encoder that includes the priority function. So if two or more input are equal to 1 at the same time, the input having highest priority will take the precedence. So which means, so as per the encoder, one output should be activated at a particular time in order to have output. But if your input is activated, more than 2 input are activated at the same time. So if that is the priority encoder, the output will be display which have the highest priority. So if you compare this one output, for example, when denote is high, so your output is 0, 0. And when D3 is high, your output is 1, 1. So when you give input denote and D3 at the same time, high jimbachin, your output display will be from D3 because of highest priority, 1, 1. So therefore output will be display at D3 instead of D0. Now if all these D0, D1, D3 are on, that is input are on, high 1, 1 jimbachin, so the first output display will be D3, then D2, D1 and D0. So it is mentioned out here, if 2 or more input are equal to 1 at the same time, the input having the highest priority will take the precedence. In addition to 2 input X and Y, the truth table has third output designated by letter V, which is valid bit indicator that is set 1 when 1 or more input are equal to 1. If all the input are 0, there is no valid input and V is equal to 0. So this V is indicator whether you have input all equal to 1 or not. So when you have D0 to D3 equal to 0, so none of the input is 1, so therefore your V will be 0. If you have your input, either your input is 1, so V should equal to 1. So it means it indicates your input has 1. The truth table shows D3 has the highest priority as XY equal to 1, 1, and D0 input with the lowest priority as XY is 0, 0. So D2 has the next priority and D1 is after D2. Now with this we will we come to the end for this session. In the next session we'll look into decoder. So if you have any doubt, please don't feel hesitate to contact me at any time. Thank you for listening.